Hello there, another lesson here on probability exercise 16c, looking at tree diagrams. But of course we've seen tree diagrams loads before. We saw them in years 10 and 11 for GCSE. We saw them last year in year 12 when we first revisited probability. And we're seeing them now again. But notice we're also now starting to think about a variety of different notation. So for instance, over here I've got the probability A happens and the probability B happens. Now technically this is the intersection of, but as far as we're concerned that means and A happens and B also happens. Whereas this one says the probability A happens and B does not happen. Of course that's what happens when you get this tree diagram. A happens and B doesn't happen. So it does seem reasonable this. I suppose I could make this a bit clearer. This is that B happens here. This is that B doesn't happen. This is that B happens. And this is that B doesn't happen. That might make that a bit clearer. And notice we've got these given probabilities. This line, of course, means given. So this is the probability that B happens given that A also happens. So we have already found out that A happened at this stage. So we're just now saying what's the probability of B having given A. And notice some of the others. Probability of B happens given that A doesn't happen, etc., etc. So you'll notice we've got some given probabilities, and that's what I mean by this line here, including conditional probabilities. So let's do an example. So this is all about history exam papers, it seems. Layla has a test at the end of each week for history. She revises for a particular test. Layla estimates that there's an 80% chance of her passing. Okay, so so my gut feeling, without even really seeing the question here yet, is that she revises or she doesn't revise. Is my gut feeling as to what this is, and then she passes or she doesn't pass. She passes or she doesn't pass. That's what I think this is. She estimates as if she revises, there's an 80% chance that she will pass. So is that 0.8 there? If she revises, there's 0. If she does not revise, there's a 30% chance of passing. I think that's 0.3. And of course, as soon as you get that 0.8, this one becomes 0.2. This one becomes 0.7. Now, do they tell us these here? The probability that Layla revises for a test is 3/4, yes. So I have set it up right. Obviously, that's a quarter. So these are given probabilities. And I suppose it's only required that we care about that if it starts giving us some dodgy notation. The probability that she revises is that what proportion? Notice this is another word for probability, really. Of her history test should Layla expect to pass? Yes. So she passes these and she passes these. So the probability, I think, of passing is the combination of both of these two things. So I think it's that times this, so it's 3/4, times by the 0.8, plus a quarter times by 0.3. Oh, these questions are always fine once you've set them up. Once you've got the correct tree diagram, I think they're pretty straightforward. Just typing it in now. I get 27/40. Whatever that is as a decimal as well. What's my answer say? 27/40. So we're on the right lines. Second example. I think there's only 3 examples on this, so I suppose it's fairly straightforward. If it is raining in the morning, there's a 90% chance that I will bring my umbrella. So it's either rain and umbrella is my gut feeling. So without even really reading the question, I'm going to say that it is. If it is raining or not raining, umbrella, not umbrella. Now it could be the wrong way around that. Let's just see. If it is raining in the morning, there's a 90% chance. But presumably there's a 10% chance I won't. If it is not raining, there's a 5th chance of me taking the umbrella. Well, let's just do that as a decimal, 0.2 and 0.8. On any given morning, the probability of rain is 0.1. So 0.1 and 0.9. This is exactly the same, really, isn't it? What's the probability I take my umbrella? I take my umbrella there and there. So probability, this is part A, umbrella, equals, I think it's 0.1 times 0.9 plus 0.9 times 0.2. If I'm not mistaken, that's 0.27. I'll type it in. 0.1 times 0.9 plus 0.9 times 0.2 times, again, 0.9 times 0.1 plus 0.9 times 0.2. 0.27, there you go. Should have just trusted my instincts. And part B, what does B say? It says, if you see me with my umbrella, what's the probability that it was raining that morning? Oh, right, now this is a given probability. This is the other way around. If you see me with my umbrella, what's the probability it was raining? So we want the probability of rain given I'm with my umbrella. Now to do this, we can use the formula, the probability of rain given umbrella. Now, let's just remind you of the formula up here. The probability of A given B. Now, this can be written as B given A as well, so just be aware that it may not exactly match the version you've got. But you basically say the probability of both of them happening divided by the second one, probability in this case of B. So on this one, it's going to be R and rain in an umbrella divided by the probability of the second one, which is U. Now, of course, rain in an umbrella is, what is it? It's rain and umbrella. So that's 0.1 times 0.9, which we presumably realize is 0.09. And I divide by the probability of getting the umbrella. Now, the umbrella bit is why we did this bit up here, 0.27. I think that's a third, because 9 divided by 27 goes in 3 times. Both of them right, good. Notice the use then of this formula when we got a given probability. Ooh, don't know what that's pointing at. And then our final example then, the probability of an acorn landing more than 2 meters from a tree is this. Some then germinate. Now the only question is, and I suppose this is something that you need to be aware of, this is either, and this could have been on all of these, this could be it lands so far from a tree, so we'll say 2 meters, and we'll say, it's more than 2 meters, or not more than, a bit annoying, isn't it? 2 meters. And then it could be it germinates, or it doesn't germinate. Germinates, or not germinate. Now that could be the way around this question is, but I just want to highlight the fact it could be the other way around. It could be they give us information about germinates, then not germinates, and it's more than, I'm going to go like that, and not more than, and not more than. And to be honest, until you actually read what they tell you, you don't really know which way round this is. So what have they told us? And the probability it lands more than 2 meters, I think it's this way round, simply because this is just a straightforward. This is 80%. So I think it's this one, 0.8 and 0.2, but I'll read on. Of those that land more than 2 meters, yes, it's 20% will germinate. So therefore that's 0.8. Those that land less than 5%, so this is 0.05 and 0.95. So although it wasn't this one, I'm pleased I've shown you that, because what that effectively does is highlight, if they started off talking about exactly the same thing of landing trees, and then they gave us this probability and this probability, and these were the given probabilities, then we'd have to use this one instead. But instead, I can now get rid of all this stuff, because it's definitely the way round, which I was tempted to write it straight away, but let's go back to our pen. So what's it say? What's the probability that it landed more than 2 meters from the tree? A seed germinates. Ah, right. So what I think I need to do is I want the probability that it lands more than 2 meters from the tree, given the fact that it germinates. That's what I think I need to find out. Because it says a seed germinates. What's the probability of landing more than 2 meters from the tree? Now that is not obvious, I don't think, that that's what we need, but that's what I think it is. And using what the logic I had before, it's m and g divided by the probability of g. Now, probability of germination, the bottom one's relatively easy. Let's just do these separately. Probability of germination is easy. I think it's you germinate there, you germinate there. Yeah, so that one is these two end up germinating. So it's 0.8 times 0.2 plus 0.2 times 0.05. I might have done actually the hardest one first, but never mind. So what is that? That's 0.8 times 0.2 plus 0.2 times 0.05, 0.17. So that's the bottom bit. I now know is 0.17. The top bit is actually, I think, the easier bit. I should have done that first. M and G is more than that and that. I think it's just the 0.8 times 0.2, which is 0.16. So this is that divided by this is 16/17. I've got 0.941. I assume that is 16/17. 0.941, yes. So this is correct. It doesn't matter. My answer is better here. So we've got 3 questions there. That highlights what we'll do. We'll probably do a couple more at the start of the lesson, but hopefully now that's a good reminder of things that we've seen in the past. But with this a bit about the conditional probabilities as well, and notice again we've used this formula. So in class we'll look at exercise 16C. Okay, thank you very much.